Hi everyone, welcome to our video on finding the area between two curves where they give us just the two curves and then we need to figure out where to start with our a and b on the integral. Well, kind of no matter what, when you have to find the area between two curves, first step is still to sketch it, and especially since we could use a calculator, it makes it pretty nice. So not much different between these problems and our first couple on the previous pages. Okay, so I'm going to sketch it. I'm going to use my calculator. So y equals 9 minus x squared. And then y equals x minus 3. Okay, and then let me zoom out so we can see it. Okay, so there it is. And then what we really want, well, what's really nice about these problems, you just have to click it, especially with Desmos. There's the intersections. So x equals negative 4 is where it's going to start, and x equals positive 3 is where it's going to end. All right, so then let me make this sketch, and we'll label those points. All right, so our sketch was something like this, where I have the parabola, and then I have something that's pretty good, I think. Okay, and we have, here's this point that's important to us, which on our picture, again, let me get it, I forgot it. Negative 4 and negative 7 and 3 and 0. Okay, so negative 4 and negative 7, and then this one was 3 and 0. Okay, so what we have, this negative 4 is really the a, because that's where the smallest x value occurs, where we have the area between, and we'll fill that in. So a is negative 4, and then b is the biggest x coordinate that contains the entire area. So we're trying to find this area right here. And then let's also go ahead and label. The parabola in our picture was the top. So top is 9 minus x squared. And then the bottom is the x minus 3. Okay, so those are the two functions that we'll use. I'm just going to go ahead and circle them in our whole setup. So we have the integral where it begins and where it ends, and then the two functions that will be subtracted. Now, if you can't use a calculator to find the intersections, so I just use the calculator and it's super fast. If you want to try it without a calculator, the intersections is to set your two equations equal to each other. So we would just do 9 minus x squared equals x minus 3. And then we would have to solve this by using Pythagoreans, or not Pythagoreans, by using the rules for quadratics. So I would add the x squared over. So we have x squared plus x, and if we subtract the 9, we'd have minus 12. Okay, so, and I'm doing it kind of fast, so just to save time, and then afterwards we could factor, and it looks like it'd be x plus 4 and x minus 3, and then solving these gives us the negative 4 and the positive 3 to where we would start. Okay, but again, the calculator is super fast. It's really nice. Okay, so take advantage of the tool. Okay, but then now let's set up our integral. So the area between those curves would be, again, just think your top function minus your bottom function, and make sure they're in parentheses. So, and let's set up where it begins. It begins at negative 4 and ends at 3. Okay, so our top function was the 9 minus x squared minus the bottom function, which is the x minus 3. And then we put the parentheses, dx, just like that. Okay, and then now, like most problems, we'll just simplify. So we have our integral from negative 4 to 3. We have 9 minus x squared minus x plus 3. So we just distributed the negative. And then now let's simplify. I'm going to put it in descending order. So we have the integral from negative 4 to 3. Negative x squared is first, and then minus x, and then it looks like it's plus 12 at the end. And then dx. And then now this is ready to do the integral. So we can now do the antiderivative of all terms, and I'm going to put it to the side here, parentheses. Okay, so the antiderivative of the first term would be negative x cubed over 3. And then the second term is minus x squared over 2. And then the last term is 12x. And then we have our vertical bar, negative 4 and 3. Okay, and then now it's the same old process. Let's get the 3 plugged into all the x's. So we've got equals parentheses, negative 3 getting cubed over 3 minus 3 getting squared over 2 plus 12 times 3, parenthesis. And then we have minus the negative 4 going in. So we have negative 4 cubed over 3 minus negative 4 squared over 2 plus 12 times negative 4. Again, it's a little tough there, sorry. Okay, and then now is where I would use my calculator again. This time around, I'm going to do it in one giant step, though. So on previous problems, we can see in the work from previous problems, I usually did in multiple steps. But let's try one other. Let's try a different way. So what I'm going to do, though, is again, this calculator is real nice. I'm going to copy exactly as I see it in the blue. And that's why I use those parentheses to really help. So I have negative, and then parenthesis, 3 cubed divided by 3 minus, and then parentheses, 3 squared. Move the arrow, divide by 2, plus 12, parentheses, 3, parentheses. Okay, so I've got this. I'm going to copy it. So I'm not going to hit enter, though. I'm just going to copy it, and then let's do the minus. Let's paste it, and then now let's go through those 3's and parentheses and change them to negative 4's. So negative 4, negative 4, negative 4. There it is. So that's it in one big giant step. Let's press enter, and then if it changes it to a fraction, that's nice. There we go. Okay, so that's all in one big step. So this is the final answer, 343 over 6 as a fraction. Okay, so we're done. I'm just going to copy it down. Okay, sweet. Okay, so again, copy and paste. Desmos is real nice with that. So this scientific calculator is real good for our order of operations. The graphing calculator is real good to get the initial picture. All right, so let's do one other. Let's find the area between these curves. Well, starts off the same way. Let's sketch it. Okay, so back to our graphing calculator. I don't need these two anymore. All right, I've got x to the 5 divided by 3, like that. And then I'm going to press enter. And then our second one is the square root of x. Okay, and then we can see, oh, that's real small, but we can see there's the area that they would be talking about. Let's see where it begins. So where they intersect is 0, 0, and 1, 1. Okay, so that's where it would begin. That's where it ends for our x values, and then we will set it up with our top minus the bottom. Okay, so let me draw in this curve. Okay, so we have something like that, and then we had something like that, and they intersected at 0, 0, and 1, 1. Okay, and then we have I'm going to color it in red. Well, that would be our a value. So a is 0. So that's where the integral begins. And our b is 1. So it's the x coordinates. Okay, in case they were different y coordinates, be careful. Just like on our first one, it was the x that was important, not the y. Okay, and then let's see. The top function, let's go back to our picture real quick. So the top function, they did it in red. Or I did it in red. So it's the square root function. So the square root of x is the top. Okay, so let's label that. Okay, so the top equals the square root of x, but probably better to just go ahead and rewrite it as a half power. Okay, so there's the top. And then our bottom one here, I'm gonna put it down here. Bottom equals the x to the 5/3. Okay, so I have them labeled top, bottom, and then now let's set it up. Our area then is equal to the integral starting at x equals 0 to x equals 1. Our top is the x to the 1/2 power minus the bottom, the x to the 5/3. And let's put them in parentheses just for good habit, and then just throw the dx at the end like normal. Okay, and then this is ready to go pretty much. Let's just instantly do our integral. So it would be x to the 3/2, and then 2/3 would multiply the front, and then minus x adding 1 would be 8/3, and then reciprocal is 3/8 in the front. Okay, and then it goes from 0 to 1. All right, and then just like the last one, now in blue, I'm plugging in the 1. So I have 2/3 times 1 to the 3/2 minus 3/8 times 1 to the 8/3. And then always minus 2/3 times 0 to the 3/2 minus 3/8, 0 to the 8/3. Okay, so there's our setup. And then now, one more time, I'm just going to go to the calculator. We'll plug it in. You might know it without needing help. That's fine. I'm going to do it with the calculator, though. Okay, so scroll, new line. Okay, so parentheses 2 divided by 3, parentheses 1, parentheses to the 3/2, and then minus 3 divided by 8, parentheses 1 to the 8 divided by 3, parentheses. Oops, one more arrow, parentheses. Okay, so there's the setup. And then I'm going to do it just like I did the last one. Let's do minus, and then copy and paste the same thing, but change these to zeros. And there we go. Let's press enter, and then let's see if it changes to a fraction. Yes, 7/24. And that's it. We got it. Okay, so this whole thing equals 7/24. Okay, so that's that. So notice on these problems, if they don't tell you the x equals like they did in these first ones, so that when they give you these x equals, that's where they want you to start and end the integral on. If they don't give it to you, well, not much of a difference, especially with how nice this technology is. Just plot it and then see where they do intersect on your actual graph. Okay, and then from there, integral of x equals the smaller number to the bigger number, and then the top function minus the bottom function. Okay, so that's our area under a curve, area between curves. If you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.